All right, good afternoon and good morning for people everywhere across the world. It's a pleasure to present our work on on building a climate risk assessment tool. For context, this was a project that CSTEP undertook along with the Pondicherry Department of Science and Technology. They have a climate change cell that's hosted within this department that was sort of interested to look at climate risk for the Puducherry region in India. Some of you might be familiar with Pondicherry, but if not, Pondicherry is kind of one of those regions where you might be familiar with the Pondicherry town, but it's actually a union territory that's split into four regions. And these four regions are all actually in different states. So you have Puducherry and Karaikal that are in Tamil Nadu. You have Yanam, which is also part of the Union territory, which is in Andhra Pradesh, and you have Mahe, which is a small portion in Kerala. So these four regions you can see are quite small and they all are classified as Pondicherry Union Territory. And the reason why it's fragmented and like that is because these were earlier French colonies. And post independence, these regions still kind of wanted to maintain some of their legacy and their culture and heritage. And so the government kind of decided not to integrate them within the states that they're in, but to retain them as a union territory. Um, so that's kind of the geographical context of Pondicherry. And so the Pondicherry government kind of works independently as a government of a union territory. Um, and so when conducting this risk assessment, we can't just confine it to the Puducherry, the capital region. We had to kind of do it for all these regions, these tiny regions for Mahe, Yanam, Karaikal, and Puducherry. So just moving ahead, we based the entire, oops, sorry. We based the entire assessment on the IPCC AR5 risk assessment framework, which is not new to anybody here. So we kept this as our base for thinking about risk, for thinking about hazard, exposure, and vulnerability. Um, and yeah, so the idea was to kind of um, do hazard, vulnerability, and exposure assessments for all these four regions and present that as part of an interactive query-based, dashboard or platform. So that's kind of the idea behind CRAT. And want to kind of reiterate that this was sort of a co-creation, the tool that we built, and this was really at the heart of the tool. So right at the inception of the project, the Puducherry Climate Change Cell was very much on board. So we actually did a couple of stakeholder engagement meetings with them at Puducherry to basically kind of set the to just to ensure that all of us are on the same page. So from understanding what hazards are important to Puducherry, what is exposed, the vulnerability, all of that was done in conjunction with, we had close to 21, approximately 21 line departments from the Puducherry government. And what I mean by a line department is like a department of, roads, your transport department, electricity, tourism. These are all very specific and niche departments. They were all present. And so this was done to kind of get everybody on the same page, but also kind of share indicators with them and say, this is what we are thinking, what do you think? And so this was a very fun consultative exercise where, we had lots of debates. It was engaging, and of course, these kind of vulnerability indicator discussions are something that we've done in previous projects as well, even with some of you on the call over here. So we followed the same process for this, and we arrived at a set of indicators across hazard, exposure, and vulnerability that we all kind of agreed upon. And that was kind of the heart of our engagement. And so we agreed to share data with each other. And the way it was done was that some of this data did not really need the government to step in. It was from secondary sources or they were climate models. But for a lot of the other data, especially for exposure and vulnerability, these were procured directly from the government departments. So moving on, I'm just going to kind of talk about like the three sections that we assessed. And so as you can imagine, the climate risk process itself is a very multidisciplinary exercise. So most of this work was done completely in-house. We have modelers within the team that kind of did different parts of this work. I'm going to, do my attempt of trying to explain all of it. So let's see how that goes. So just to kind of understand the methodology of the hazard component, we selected four hazards: drought, heat wave, flood, sea level rise, which followed the SPI index for drought, IMD criteria for heat waves. You have, Karaikal, Yanam, Mahe. They're all coastal towns. Mahe, which is also a hilly region. So IMD has, criteria for what is a heat wave for each of these regions. So we just kind of followed that. For floods, we use your return periods to look at probability of occurrence and HECRAS to compute, the spatial extent of floods. Sea level rise, we basically took the number of years that the sea level rise went beyond a certain threshold, and employed like a bathtub model to look at the inundation caused due to sea level rise. One hazard that we couldn't compute, but the Puducherry government wanted us to do was cyclones. But at that time, we didn't really have the ability to do that within ourselves to compute cyclones. But we realized that that's kind of a risk that's a climate hazard that a lot of coastal regions in India face. But the technicalities of computing it are also kind of challenging with the kind of timelines that we had. So that was one hazard that we couldn't do for this project, but hopefully in the future. So just looking at drought, some of your key results are that most of the regions all have moderate drought. And because these regions are so tiny, your data also was kind of was very large. And so even for areas like Mahe Extra, which are really tiny, you just get kind of one grid that's overlying these regions. So all of them kind of face, moderate drought in both the current and future time periods. I'm just gonna go through some of the results for the hazards, and then we can go through the tool in just a bit.
Sahil,
Yeah.
maybe just go to the dashboard directly and show something there, some of the things there.
Yeah. Okay. Yeah. I can get to that in just a.
Yeah, the summary statistics, more than the summary statistics, the USP is the dashboard, the public visualization.
Okay.
So that will save time a little bit as well.
All right. Just a second. Okay. Yeah. So most of the work kind of sits within this dashboard, this tool kind of that we have. So if you, just thinking, yeah, you kind of get to a tool like this, and then you can enter the tool section of the website, and over here you have the ability to kind of choose between multiple different sectors. So we did the risk assessment for seven different sectors. So you can kind of choose which one you would like to see. So for example, if you were to choose something like agriculture, you can just kind of pick agriculture and then see if you want to see this for the historical or future time period. So let's say we pick historical, you can kind of then look at which hazard you want to consider this for, and you have two options. You can either kind of see the probability of occurrence of the hazard, or you can see the spatial extent of that hazard. So something like let's say flood is based on a return period, so that's fairly intuitive. You can kind of choose which return period you want to see for, and then you can kind of see the spatial extent of flooding, which should load in just a second. So yeah, so you can see how flood kind of is present in all these four regions. So once we have that, we can kind of go into your exposure section, which kind of looks at what are your assets that are exposed to the hazard. So in consultation with the PCC, these were kind of the assets that they thought were important. So you can kind of pick. You can either, let's say you want to see something like net zone area. Um, you can see your net zone area that is, I'll switch back to the flood. Just a second. Yeah, and then if I kind of click net zone area, it shows me what is that net zone area that's within the flooded areas in Puducherry. And then after that, you can, if you want to just select all of the indicators, you can do that and see just where everything is with regard to flooding. And then, of course, you have your vulnerability section, which presents all the indicators of vulnerability that we chose for, let's say, the agriculture sector. So you have the option of just clicking one or two to see what that particular indicator looks like. But if you kind of select all, you get like a composite vulnerability index that tells you what is the vulnerability in each in each region. So once you have all of this selected, yeah, once you have all of this kind of selected, you can then show risk, which then kind of gives you low to high what your risk looks like for each region. And so the way that we've done it over here is we just kind of did a method of classification where the highest risk score is given a high and the lowest is given low, and we split that into three classes. And the reason we do that kind of a classification is because we want the Puducherry government to kind of look at this dashboard and see which is the region that requires the highest amount of attention. So for the agriculture sector, and for agriculture sector to flood, you can kind of see that Yanam is your most at risk over here. And so the idea is to kind of direct attention towards Yanam. The other option of doing a classification was to kind of take all your values and just kind of do your method where, 0.0 to 0.3 is low, 0.3 to 0.6 is medium, that kind of system. But it didn't give the kind of message that we wanted to convey. Um, and so this was kind of a long discussion that we had to have with Puducherry, because since this is a kind of public tool in the sense that anybody can log in and use it, they also had concerns about, of people using it and then saying, something like Yanam is high risk, something like, Puducherry is low risk, and it doesn't reflect too well on the government sometimes. And so that was a concern. But we sort of had to explain that what this means is that this is a more of a relative scoring, and this just means that your attention should be directed towards Yanam. So similarly, you can kind of do this for either sector. You can kind of pick whichever sector and repeat the process. You can even do it for the historical um, future. So you can kind of, I mean, for the future scenario, and then you can pick whichever hazard, exposure, vulnerability, and repeat this exercise for whichever sector that you would like. So that's kind of how the tool is built. And at any point, if you've lost track of what you've selected and which indicators you've selected, because this can be a little confusing, you can always just go under something like your selected indicators and see, okay, I've picked the fishery sector, I've picked it for the future, and I've picked these exposure indicators, I've picked these vulnerability indicators, and so on. So that gives you an idea of where you are in the tool. Another thing was we wanted to ensure that users can't show risk just based on whatever indicators they choose. So we kind of insist that you have to select all your exposure indicators and select all your vulnerability indicators, and only then are you able to sort of see risk. And the reason we did that was just so that we kind of avoid people kind of doing whatever risk calculations they want to kind of um, to get results that are extremely biased. So we didn't want to do that. Or we didn't want to give that opportunity. So you have to kind of select all of your exposure, all of your vulnerability, and only then can you see risk. So that was one criteria that we made very clear. So that's kind of how the tool operates. And um, just to also reiterate, yeah, your risk was basically aggregated for all four regions. And we gave Puducherry a report as well, where we gave them two kind of risk options. We've kind of given them an intersectoral and an interregional risk, where essentially, you can see risk as between sectors. That is, um, if you can take a region and see which sector is most at risk in that region, or you can do an inter-regional climate risk, which is to look at the regions and see what is most at risk for a particular sector. So this is like the agriculture sector, and so the agriculture department can look at it and be like, okay, for drought, Puducherry and Yanam are high at risk. For SLR, Puducherry is high at risk. The rest are fine. So you have two ways by which you can kind of understand risk, and we didn't integrate both the methods into the tool because it becomes very confusing. So we kind of gave this just in the report format to them to their departments for them to use. Um, y- yeah. So the way forward for something like CRAT would be one to enable this dashboard to be dynamic and allow these data sets to be updated automatically. And right now, the tool is fairly static in the sense that these data sets aren't updated dynamically. They're all data sets that are timed, and so we would like them to have a system where things like climate, your vulnerability information, all of that can be updated as and when data sets get updated. Right now, that has to be done manually. Second is we would really love higher resolution hazard data. So right now, we had to work with gridded rainfall data, gridded temperature data from IMD Extra, which are kind of large grids. Many of them in Puducherry, we could get 4 grids, but in places like Mahe, it was just a single grid. And obviously, even the government, they still rely on 2011 census data. So for your vulnerability assessments and so on, even though government was giving us data, we found that a lot of them was just census information. Nothing was really too updated. um, then we kind of want to ensure that the tool is actually being used by the line departments of the Puducherry government. So we get a report every week, just seeing who's using the tool, of course, with like no names, etc., but just where and how many hits the tool is getting and so on. Right now, I think the tool is still in a phase where just people from different countries or different regions of India are kind of just exploring it. But right now, there is a notice being sent in the Puducherry government that the CRAT tool has to be used for their decision making. So that is in the process. So if that is something that gets institutionalized, then that's a win for a tool like this.
Sahil,
Finally,
sorry, I am coming in between. You have to
yeah.
wrap up. Yeah.
Okay. Sure. Um, yeah, just finally, just leaving three learnings for Lodestar. Many government departments, when we kind of presented the tool, didn't know that CRAT was being developed, and this was a little contentious because I think everybody kind of wants to know when something like this is happening. So I guess even for Lodestar. Finally, if we have the launch meeting and a lot of government departments are like, we had no idea that something like this was happening, we could have contributed, so on and so forth. That could really help. Data is a challenge even for the government. So a lot of the data that we had to get was from secondary sources that we had to scrap and finally just use because if it lies with different departments, getting those signatures, getting it transferred was super tough. and market research is necessary. So CRAT is still a very supply-driven tool in the sense that even though it was co-developed, we are kind of pushing it from our sense, from our side. Even PCC is kind of pushing it and saying, here is a tool, please use it. So in some sense, it is the tool first, and then the government kind of responding to that. So the burden of proof of using this tool is just completely on us. But as Suvit mentioned also, like EWS in Bangalore, just doing basic research on who needs an EWS, where can we fill that supply demand gap would be necessary, and it's something that we saw in CRAT as well. So yeah, I think I'll stop there.